Next, we'll be building our schematic for testing. So to do that, we'll go to File, New, Cell View, and we make sure our type is of schematic, and we will name this sim_min_frame. Click OK, and it will bring it up. Now first we need to create an instance for our design. We'll click Browse, go down to Pad 3, and you will see our min frame and our symbol for it. Next, we need to add our analog parts for our design, and for this design we'll need voltage source, VDC, and we need to make sure that that is at 5 volts, VDC. We will add a pulsed supply for our inputs. It will go from 0 to 5 volts with a delay of 0, a rise time of 0, a fall time of 0, a pulse width of 25 nanoseconds, and a period of 50 nanoseconds. So we will place that in our design. We'll also need supply nets of ground and VDD. The completed schematic looks as follows. Lastly, before simulation, we will add wire names to our input and output, and to do that we will click right here. So for our first wire, we'll place it as output. Make sure to click the rotation button, and then we'll place it on our output. Next, we'll place an input wire, we'll call it in, and place it there. Next, we will save our design by clicking the save button. You'll have 0 errors and 2 warnings. The 2 warnings are because your output is not connected, both unconnected nets. We can ignore that. Go ahead and click close. And now we will launch our simulation. So we will click launch, ADEL, and as we've done in previous designs, we will go to setup, environment, and add extracted. Click OK. Go back to setup and go to model libraries, and here you will add your model library. Click OK. Next we'll go to analysis and choose, and we start at 0 nanoseconds, we'll stop at 1 microsecond, and our step is 0.1 nanoseconds. Click OK. And lastly, we'll go to Outputs, Setup, from Schematic, and we'll choose our input and our output. Go back to that window and click OK. Now we can run our simulation. Once the simulation is complete, we have our waveforms for our input and output. If we click this button right here, it'll separate the strip, and as we can see, when our input is high, our output is low. When our input is low, our output is high, so our inverter is working correctly.